Hello everyone and welcome to my channel. I'm going to start another series of videos in which I will teach you how to perform simulations related to vehicular ad hoc network or VANET. The simulators that I will consider in this series of videos are SUMO, OMNET and VINS, and the objective of this series of videos is to help the students and researchers who are interested in doing their research related to smart cities, more specifically smart transportation, or to be more specific related to VANET, smart vehicles, vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to pedestrian communication and things like that. So this is the first series of this is the first video of this series, and in today's video I will show you how to simulate a very simple and basic scenario by using the SUMO simulation of urban mobility simulator. I will be using Linux operating system for all the experiments, but you can use the same on Windows operating system as well. And I suppose that you have already installed SUMO and OMNET and they are working perfectly. So that is the supposition that I am going to take. Well, to perform the first experiment in SUMO, we require to have at least 3 different files. I am going to create all the files one by one. So let us start with the first file. In SUMO, a street network, a road, a highway actually consists of nodes, or you can say junctions, and edges. Like the edges are the lines that are actually connecting those nodes or junction. So if I want to create a simple network of 2 streets subsequent or connected to one another, I will need 3 nodes, and to connect the 3 nodes I will require 2 lines or 2 edges. Okay, so let's start with the first file. The first file is about creating the nodes. Actually I will be using the code that I have already written, and I will post the link to the code so you can actually download the code from there, from GitHub, and you can run the simulation by your own machines. So this is the first file, and this is about the node. A node, here the file that you can see, they have a location. For example, the location, the x coordinate and the y coordinate. The y coordinate is same while I am changing the x coordinate. And as I am going to simulate a 1 kilometer highway, so you can see this is actually the length in meters. The x coordinate started with 0 and ending with almost 1,000 meter, which will give you 1 kilometer highway. As I told you that I am going to make a highway of 1 kilometer, so I actually need 3 nodes. So here you can see the node and their location. Every node that we are going to create required an ID that we will use later on in this experiment. So I give it a very meaningful ID, that is the name representation for this node, that is right to left 1, right to left 2 and 3. Once you have created this file, you will need to save it. So for simplicity, I am going to create a folder here. I give it the name of first because this is my first experiment, and I'm going to save every file in this folder. Save this file on the desktop in the first folder. We need to give it a name, so I'm going to give it the name of first. Remember, you need to give it an extension. So the extension for the node file is .node and .xml because it is an XML file. Save it in the first folder, first.node.xml, and that's it. Now I need a second file, and that is the H file. H file is used to connect the nodes that I have created here. Okay, these 3 nodes. So I'm going to connect them. So I need two edges, one edge to connect these two nodes and the second edge to connect the previous two, the last two nodes, like 1 to 2. To connect 1 with 2 I will need an edge, and to connect 2 with 3 I will need another edge. So let's create the edge file. Again, I have already written the code. So this is the code. You see, I am creating two edges, one to connect 1 with 2 and the second to connect 2 with 3 from 2. This is the syntax. And as I give ID to the node, I need to give ID to the edges. So the ID for the first edge is 1 to 2, R is for right, and out R. Okay, you can also define the number of lanes. Each road, as we know, have different lanes, so you can define the number of lanes per road. It could be 1, 2, 3, 4, as much as you want. Now we need to save this file in the same folder first, but here I'm using the same name first because this is the first experiment, but the extension here is going to be different. The extension is edge.xml. Okay, so this is our second file. Now we need to create a network. We need to link these two files, or to merge these two files, and for that we need a tool, and that tool is called netconvert. And when you install SUMO, this tool will be automatically installed on your machine. There is also a graphical version available, which is the NetEdit, but I am using the command-based version. So first I need to change my directory to the first folder, and then I am going to call the net tool. The command, I will provide it also, is netconvert. I need to provide the input file. So I have two files, the node file, which is the first.node.xml, and the edge file, which is the first.edge.xml already created. And I need an output file, so I need to give a name to the output file. The name that I am using here is first.net.xml. So you know, we already have the node file, we already have the edge file, and now we are creating the network file or net file. So this is the command. Let us execute the command. Okay, success. Ignore the error, ignore the warning. Success. Now I have created the network file, and if you see the folder first, you will see that now we have the third file, the network file. Okay, that's it, the three important components. But that is not the whole story. We still need the traffic. Now we have created the road, 1 kilometer highway with three lanes, but still we need the traffic. So for that I need another file, and that is the route file, the third component. So the code is here. What I'm doing, I'm going to define a vehicle type. Okay, the ID, like I give ID to the node, I give ID to the edges, I need to give ID to this vehicle type. So the ID here is car. Okay, and the length of the car is 5, the accelerator, deceleration, the sigma. You don't need to be worried about all these. If you are interested, you can visit the SUMO tutorials or the SUMO website for the details. Sigma is the driver experience, maximum speed of the vehicle, and the color of the vehicle. Different parameters that you can define inside this. Okay, now I have a vehicle type. I need to define the route that is taken by this vehicle. So the route is like right to left traffic, the ID. And what are the edges? So the edges is from here. You have two edges, so you can define the edge, the route here by from these edges. The car will drive through these edges or these lines or these roads. 1 to 2 out R, two edges, that is 1 to 2 R and out R. You know the importance of the IDs. I give IDs to the edges, and now I am using those IDs here in the route file. So I have defined a car, a vehicle type car, and whenever I call this car, it will take the edges, these edges defined here. Now I have defined the route. Now I need to define the vehicle. So here in this tag vehicle, I am going to define the depart. When you start the simulation, after the first second, a vehicle will depart. Okay, and the ID of the vehicle is vehicle 0. What is the route taken by this vehicle? This is the route taken by this vehicle. I give an ID to the route, and the route is made from these two edges, and this vehicle 0 will follow this right to left traffic. You can give any ID to it. And what is the type? The type is car. You can define different types of vehicle: ambulance, pedestrian, bus, private vehicle, etc. Okay, there are different types of vehicles that you can define. And now it's time to save this file as well. So I'm going to save this file. I'm using the same nomenclature. There is the first, but the extension here is root.xml. okay, in the same folder. That's it. Now if you go to the folder, I have created the node file, I created the h file, I create the network, and now I define the route, and I also define the traffic and the type of vehicle and the edges that it will take. Now it's time to glue all the files, and for that I will create the final piece of file, that is the configuration. The SUMO will accept only this file, so I need to define. I have a net file, don't need to define the node and edge because the net file already merged those two pieces, and the name is first.net.xml. I have a route file, the traffic file, the vehicle file, and that is defined inside the first.root.xml. okay, you also need to define the start of the simulation, the end of the simulation, the step taken by the simulation, but you don't need to be worried about these parameters for the time being. The important thing is that we are going to use two files, the network file and the route file. Save this file in the same folder by giving it the name first. I'm giving the same name just to make it clear, or not to make the things confusing, but the extension of each and every file is different. So here the extension is SUMO CFG, SUMO configuration file. Save it in the same folder. That's it. Now we have all the required files in the same directory. It's time to run the simulation. The simulator is SUMO, as you know. So first I have already set the path for the simulator, SUMO GUI, so I'm going to call it directly from here. Okay, you need to open the folder, and the folder I know it is on the desktop, first folder. You see, first SUMO CFG, this is the file. One important thing before running the simulation, give it some delay so that you can see what is happening inside the simulation. If you do not define this delay, the simulation will occur very quickly. And now it's time to open the SUMO configuration file. Hey, this is the scenario. The scenario has been loaded. This is 1 kilometer highway. I defined 3 lanes, so you can see the 3 lanes, 1, 2, 3. Okay, to run the simulation, you can have the option here, run. You can run the simulation from here. I define a single vehicle, and you can see the vehicle here is like from right to left. Okay, it's traveling. You can see the simulation in different views. Real world, I like this one because the car will appear like a real car, and you see it's traveling toward its destination. So I created node, I created edges, I linked them by calling the net edit tool, and then I define the route file. Inside the route file I define a single vehicle. You can define more vehicles, you can define flow of vehicles, you can define traffic from another side as well, but that I will left it for the second experiment. So thank you for watching the video. I will let the code available on GitHub. I will provide the links to you in the description of this video. last but not the least, I would like to thanks to FAPESP for supporting this project, and this is part of my postdoc research, and the project on which I am working is an emergency response system using fog assisted vehicular ad hoc network for smart cities. You can see the abstract here. You can visit this website to have a more idea. Thank you so much for watching the video. Take care and goodbye.